So kinematic equations of motion, and now we are going to do the derivation by calculus method. Now I know that my velocity, okay, what is my acceleration? Is it not dv by dt? It is the derivative of velocity, rate of change of velocity. So can I say that dv is equal to a into dt? Correct. Now here I will integrate. Okay, I'm going to integrate. Now uh, this I mean my u is initial velocity, v is final velocity, a is acceleration, t is the time, and s is the distance, okay, or displacement. Now here if I integrate this, see now here again I'm going to reiterate the fact that these kinematic equations, they are for uniform acceleration. That means my acceleration is going to remain constant throughout the motion, okay, throughout the course of motion. So now if I integrate this, my acceleration, it will definitely come out of the integration sign because it is constant, okay. Now what is my initial velocity? It is u. What is my final velocity? It is v, okay. And what about time? Initial time is at t is equal to 0 and t is equal to t. So my limits are going to be u to v here for velocity, and for time it is 0 to t, correct. So now integral dv, so it is going to be equal to v, and my limits would be u and v here, and it is a into integral dt is t, so that is equal to again 0 to t here, okay. So upper limit minus lower limit, so it is v minus u is going to be equal to a into t minus 0. Upper limit is t and lower is 0, correct. Therefore v is equal to u plus at. This is my first kinematic equation, okay. Now what about the second kinematic equation? Okay, for second kinematic equation, what was the equation? It is s is equal to ut plus half at square, correct. So how do we do that? My v is equal to ds by dt, correct. It is the rate of change of displacement. So obviously my I would say ds is equal to v dt, but what is my v? Is it not u plus at? So I'll just put that over here. It is u plus at dt, and this is ds. Now I'll integrate. My initial displacement is 0 to s. I'll integrate, and here what are the time limits? They are 0 to t, okay. So now this is going to be s from 0 to s, and here I am going to have my u. U is constant because see, initial velocity is a constant value that you know, okay. It's not variable. Here t is the variable, so it is going to be equal to ut here, integration of u, and for at it is going to be equal to a into t square by 2, and from 0 to t, correct. So obviously you substitute the upper limit. You have two t terms here, correct. T term is here and t term is here, t square, okay. So my lower limit anyway it is going to be 0, correct. So what I get over here is s is equal to ut plus at square by 2. I'll write it half at square, and then this is my kinematic equation number 2, okay. Let's go to the third one. For third one, I'll have to erase. I'm just going to erase this part. You can replay it if you really want to see it, but in the meanwhile I'm just clearing this. Alright, so now the third equation is v square is equal to u square plus 2as, okay. How do we do that? See, my acceleration is equal to dv by dt. Now here I'm going to use chain rule from derivative. Okay, again for this chain rule and this calculus part, okay, calculus in physics, refer to my videos in videos for calculus in physics. I'll be giving the link in the description. Okay, so this dv by dt, I'll write dv by ds into ds by dt, correct? So what is my ds by dt? Is it not my velocity? Correct. So I'm going to write this as a is equal to dv by ds into v, right? Therefore I can write a into ds is equal to v dv, and now I integrate. Okay, so integral of this is equal to integral of this. Now here I am integrating velocity with respect to velocity and acceleration with respect to displacement on the left hand side. Note that my acceleration is constant. It is going to come out of the integration sign there. Okay, what is my initial displacement? Is it not 0? And final displacement is s. What is my initial velocity? It is u, and final is v. So my lower and upper limits are u and v here. Okay, so it is s, a into bracket s 0 to s. This is equal to it would be now integral v dv. Okay, v raised to power 1, so it is v raised to power 1 plus 1, that is 2 upon 2, and then that would be from u to v, right? So this is going to be v square minus u square upon 2 when I substitute the lower and upper limits, right? And here obviously my lower limit is 0, so it is going to remain as a into s. Okay, so on simplification what I get here is v square is equal to u square plus 2as. This is our third kinematical equation. Okay, next video is going to be about finding displacement in nth second. What is that nth second and all, that we'll see in the next video. Thank you so much.